Hello everyone, welcome to part 2 of session 1 of module 6, types of test tools. In this session we will finish the remaining types of test tools. So in this session we will cover tool support for test execution and logging, which will cover test execution tools, test harness or unit testing framework tools, test comparators, coverage measurement tools, and security tools. Then we'll see tool support for performance and monitoring, which will cover dynamic analysis tools and monitoring tools. Then we'll see tool support for specific application areas, and finally tool support using other tools. So let's get started. So first classification is tool support for test execution and logging. So some of the tools for supporting test execution and logging are test execution tools, test harness, unit testing framework tools, test comparators, coverage measurement tools, and security tools. So let's see these tools one by one, the classifications one by one, and understand different features and who uses these tools most. So let's get started with test execution tool. Test execution tool is also known as test running tool. Test execution tools record the manual tests, which can then be played back and tested in future builds. So test execution tools are basically record and playback, or you can say nowadays it's an automation tool, which can record your manual test steps, and then you can save those manual the recording, and then you can finally replay them in the future builds to see whether those tests or the manual steps that you have performed while recording the test pass in the future releases or future builds. Then test execution tools use a scripting language to drive the tool. So the baseline in the test execution tool is the scripting language. So if you have a bit of idea about QTP, Quick Test Professional from HP, then that has a scripting language, VB scripting language support. So you can record and play back the manual test steps that you perform on any application, software application, or you can use scripting language to extend the framework to design more complex automation framework from QTP. So any software automation tool supports some kind of scripting language. So what are the features of test execution tool? So the first thing is that you can capture test steps while manual test case is executed. So there is a feature for record and playback in any test execution tool. Then you can store the expected results in the form of object or screenshot to compare to when test is played back next time. So you can have, basically these are known as checkpoints in test automation tools. So you can have checkpoints in the form of screenshot or in the form of object. For example, on this page there should be a submit button, so you can identify that submit button object, and you can store it in the tool to verify whenever the next execution is done, whether that object is present on that page or not. So similarly, if you want to verify some text on a page, you can store that text or a screenshot of the page and compare it with the actual result next time when you play back that test. So capability of storing the expected results or capability of having checkpoints is another feature of the test execution tool. Then support for keyword driven or data driven testing. That's another very common kind of data driven or keyword driven frameworks that are most widely used in automation testing. So automation tools also support keyword or data-driven testing frameworks. Then logging test results and measuring time taken to execute tests. This is very common functionality which every tool, automation tool or test execution tool provides, that you can log the test results, what the test results are, and then measure how much time it took to execute those tests. Then support for programming language to customize recorded tests. There is always a support, since scripting language support is always there, so you can customize your recorded test, because your recorded test lack the functionality of programming language. So like looping or more complex kind of framework is not supported with just record and playback thing. So you can use programming or scripting language to customize your recorded test to make it more effective and powerful. Then support for dynamic comparison of screens, elements, links, and objects. So you can have comparison of screen or elements or objects of the page. That's another feature of test execution tool. Then these tools are used mostly in regression testing, because regression testing suite is the most re-executed test suite. So with any build or any release that you get for your software, you need to execute the regression test suite. So regression test suite is the most important or best candidate to automate, because that needs to be executed again and again with every build. So test execution tools are most widely used for regression testing. Then it is used mostly by testers and very specific by like automation testers, whosoever is handling the responsibility of automating the test cases, regression test cases. Then the second is test harness or unit test frameworks. These are mostly used by developers. So test harness and unit testing tool provide support to developers during unit or component testing. So unit testing tool provides support to developers during their unit or unit integration testing. Test harness provides stubs and drivers which are used during unit testing. So test harness basically provides the stubs and drivers. So we already discussed about stubs and drivers in previous modules. So stubs and drivers are the missing components, you can say, which needs to be so if you are developing software, every module of the software is not necessarily that every module will be ready while you start the testing or while developer is kind of doing the unit testing. So test harness helps them to use stubs and drivers which are for the missing components, and keep on building their code, or keep on going ahead with the unit testing. Then unit testing frameworks help to automate unit tests during unit or component testing. So unit testing frameworks, most common unit testing frameworks are JUnit or NUnit. So these are the frameworks which are most commonly used by developers. So they help to automate unit tests for developers. Then what are the features of unit testing framework? It provides inputs to the software being tested. Then it provides storing test output. So whatever test has been executed, it records the test output, the results. Then you can execute a set of tests by unit testing framework. So for example, you have JUnit, you can have a test suite, so define a test suite in JUnit and execute a set of tests. Then you can record test outcome, whether that unit test pass or fail. And it supports debugging. So if unit testing framework is integrated into your Eclipse IDE, so Eclipse IDE has all the feature of debugging. So unit testing framework provides support for debugging as well. You can debug the code and see where the problem is. Then it provides coverage measurement at code level as well. So these are some of the features provided by test harness or unit testing framework. Then these are used mostly at unit unit or component testing or unit integration testing, and these are mostly used by developers. Then test comparators. So test comparator compares post execution results. So test comparator, the main role of test comparator tool is to compare the result or outcome that is that you receive after executing the test. So a test comparator automates comparison of actual output with expected output. So this comparison is mostly automated. So actual output with the expected output is kind of automated with test comparator. The test comparator is usually a standalone tool. So test comparators are usually standalone tool. So this feature is built in most of the tool, but they are also a standalone tool wherein you need to compare a lot of test data or test outcome with the expected outcome. So it is usually helpful to compare large amount of database record with the expected data. So test comparators are mostly very useful when you're doing database testing and you want to compare the large amount of database data, whatever data is there in the actual test data, test environment data with the actual data, with the expected data. So test comparators are very useful at that kind of situation. What are the features of test comparators? It helps in post-execution comparison of stored data, like comparing differences in database contents or test results. So it's very helpful in comparing the differences in the database contents. Then it provides functionality for dynamic comparison, comes built in with test execution tools. So there is a feature of functionality of dynamic comparison as well, which is mostly built in test execution tools. For example, if you're using any test automation tool, it dynamically compares the objects present on a page or the text present on the page while the test is being executed. So that dynamic comparison comparator feature is already included in test execution tools. But test comparators also come as standalone, which are mostly used for comparing differences in database contents with the test results. Then the third feature is provide masking or filtering feature to mask or filter specific data. That's another feature of test comparator. It can mask some data and just compare the data set of data that you want to compare with the actual data. So these are some of the features provided by test comparators. These are used mostly throughout the SDLC because when developers are developing, they might use it. When testers are doing some testing, these tools, these comparator tools might be required there. When database testing is going on, so these test comparator tools are almost used throughout the SDLC. Then these are used mostly by testers and developers. Then the coverage measurement tools, these are usually mostly used by developers. Coverage tools helps you to answer the question, how thoroughly have you tested? So coverage measurement tools are the tools which give you a fair bit of idea how much testing has been done, or what test cases cover what part of code. All right, so or which part of code is still not being exercised by the set of test cases that you have already written. So coverage tool identifies the coverage items like statements, decision, and then provide percentage of coverage, percentage of code covered by your test. So there are coverage items in the code like statements, branch, decision, and then your coverage measurement tools provide whenever you execute the set of test cases that you have written, then your coverage measurement tools captures the code that is being covered by the set of test cases that you are being executing, and it shows that coverage percentage as a result. So sophisticated coverage tools also provide help to identify extra tests that need to be added to exercise missing coverage items. So sophisticated coverage tools also provide help to identify extra tests. So suppose you have 100 test cases and your coverage tool identifies that your statement coverage with that 100 test cases is just 70%, and your decision coverage with those 100 test cases is just 65%. So there are many coverage measurement tools which will help you to identify more test cases so that you can get 100% statement coverage and 100% decision coverage for the code that you are testing. So it will identify some tests which you can later on add and see how the coverage, code coverage has improved by adding those tests. Then what are the features of coverage measurement tools? Ability to instrument the code or identifying the coverage items. So that's the first feature, that it identifies the coverage item like statements, decisions, conditions. So it identifies different coverage items of the code, and you can the ability to instrument the code as well. Then calculating the percentage of coverage by suite of test cases. So it calculates the percentage of coverage by suite of test cases. So suppose you have a suite of tests which has 100 tests, then it provides the percentage of code covered by that suite of 100 test cases. Then it generates the coverage report. That's kind of the percentage of coverage report. So reporting functionality is there. It identifies the extra test inputs for missing coverage item. That's another feature. And then it has ability to generate stubs and drivers if coverage tool is part of unit testing tool. So in case, so most of the code coverage tools for Java development are kind of plugins which you can plug into Eclipse integrated development environment. So those plugins have ability to generate stubs and drivers if they are part of your unit testing tool. Then these coverage measurement tools are mostly used during unit or component testing and mostly used by developers. Then we have another classification of security tools. Security testing tools are used to test software or system security from external attacks. So nowadays, since there are many malicious users over the internet who try to hack the systems or the software and try to steal the data from the organization, so security testing is very important nowadays. So security testing tools are used to test software security from external attacks. Then a security testing tool analyzes the network, database, any coding issues to figure out any loopholes in the software. So these tools are used to so for example, nowadays you have different security testing tool which can inject SQL, or they can analyze the network and see the traffic flowing on. So these tools are used to basically find the network traffic and then any coding issues, SQL injection, and see if there are any loopholes in the software. Then what are the features? Support for finding vulnerabilities with database design, code issues, network issues. So it has support to find any vulnerabilities with any design. So that support is there in security testing tool. Then it identifies any virus in the software system. It scans, it can scan your system and identify any virus there. It can simulate the external attacks, for example, denial of service attack. So you can initiate denial of service attack with the security testing tool and see how your software behaves and whether whether your software is able to handle those attacks or not. So that kind of external attacks you can simulate and detect them. Then support for packet capturing and port sniffing. This is another network analysis which is mostly done by Ethereal, which is very popular packet capturing port sniffing tool. You can see what traffic or what packets are flowing over the network if you over the network for specific node, and see if everything is passed on and encrypted and cannot be decrypted easily. So that's another support that is provided by security testing tool. Then you can identify the weakness in password policy for applications. These tools, security tools, also provide help with the password policy and the weaknesses that can be there in the passwords. Then these are used mostly during security testing, and they are mostly used by security or penetration testers. So penetration testing is completely different testing which completely focuses on doing security testing of the application. So security testing tools are mostly used by penetration testers. Then the other classification is tool support for performance and monitoring. So some of the tools for supporting performance and monitoring are dynamic analysis tool, which is mostly used by developers, then performance, load and stress testing tool, and monitoring tool. So let's understand these one by one. So dynamic analysis tools. Dynamic analysis tools analyze the software behavior while it is in test or normal operation. So dynamic analysis tool, as the name itself, self-explanatory, that while the software is in operation, it analyzes the software behavior. Then what are the features of dynamic analysis tools? It provides ability to detect memory leaks. Then it identifies the exceptions in code. So the main feature of dynamic analysis tool is it can detect any memory leak in the software. So whether when the software is in execution, whether the memory whether there are any memory leaks or not. So memory leak is something while the software is being in execution, whether it fills out all the memory and there is no memory left, and finally the software either crashes or stops. So these kind of issues are detected by dynamic analysis tools. Then it identifies the exceptions in the code, if there are any exceptions during certain operations in the code. Then it also identifies any time dependency issues with the software. And these are used most during unit or component testing or during unit integration testing, and mostly used by developers. Then the second set of tools is performance, load and stress testing tools. So a performance testing tool is concerned with testing the system to see if it can handle high volume of usage. So performance testing is mostly concerned whether the system or software can handle high volume of usage. Then a load test checks if the system can handle supported number of transactions. In load testing, your main focus is to test whether if your software is designed to handle 2000 concurrent users at a time, so load test checks whether your software can handle those 2000 concurrent users on the website or not, or concurrent transaction on the website or not. Then a volume test checks if the system can handle large volume of data. So like many records in database or uploading a file with huge number of records. So volume test basically tests whether the system can handle more amount of data as your system is designed to support. So suppose your system is designed to support 2000 concurrent users. So in volume test you test with 10,000 users, so with large amount of data. Then in stress test you see what would happen if system if load or volume is beyond the design specification. So in stress test your main focus is to test the system if suppose in load test you see how the system will handle support a number of transactions. In volume test you test what will happen to the system if there is huge volume of data in either in database or in uploading a file or huge number of records in the database. So in stress test what you test is, if suppose your system is designed to handle a specific amount of load, in stress test you test if what will happen to the system if the load or volume is beyond the design specification. So suppose load allowed on a software is 2000 concurrent users at a time. So in stress test your focus is to test what will happen in case there are 10,000 concurrent users on the website at concurrent users on a website at a time, or what will happen if there are 1 lakh records in database and your software is designed to handle 50,000 records in database. So these kind of tests come into your stress test. Then performance testing assesses the response time throughput for the system under different usage conditions. Main focus of performance testing is to see the response time. What is the response time for the user or for the transaction? What is the throughput of the transaction under different usage conditions? So suppose there are 100 users, 100 concurrent users, what is the response time? When there are 1000 concurrent users, what is the response time for the user? So these are the kind of tests that are done in performance testing. And what are the features of these tools? They can generate load on the system, so simultaneous users on the website. So there are many tools which can generate simultaneous users on the website. Then they can measure response time for transactions with varied load on the system. So this means that they can simulate 100 users on the website, concurrent users on the website, and measure the response time for each user. Then they can simulate 500 users on the website and see the response time and calculate the response time for the user when there are 500 users. So they measure response time for the transactions. Then they generate response reports for different tests on system. So reporting is another very important feature for these performance load and stress testing tools. These are used most during performance testing, and these are mostly used by performance testers. Then the next set of tools is monitoring tools. So monitoring tools keep track of the status of system like memory usage, CPU usage, network performance, etc. So these are mostly just to monitor system usage, memory usage, processor usage while the software is running. So features of monitoring tools are to identify the problems with system and sending alerts. So they identify the problems with system and send any alerts. If there is high memory usage or high CPU usage, they send alerts. Then they log the real-time and historical system information. So whatever real-time information is available, they keep log of that information they monitor the load and network usage for the system. So that's another important feature, that whatever network usage is there or the load on the system, that's all being monitored by monitoring tools. Then they also suggest the optimum settings for the system. So suppose you have deployed your software, these tools will provide you suggestion about the optimum setting for the system so that your software performs with in best optimum conditions. Then when used most, this is used most during testing or production monitoring. So monitoring tools are mostly used during production monitoring to monitor how the software is behaving in production environment, but these tools are also used in testing while there is a performance testing going on. So whenever there is performance testing, load or stress test being carried out, monitoring tools are used during testing as well. And these tools are usually used by testers and system administrators. Then tool support for specific application areas. So there are some areas which require specialized tools for testing. So what are the specific application areas? So we have tried to classify tools according to different functionality and areas they cover, but there are tools which are very specific to certain application areas. So for example, we have some tools here, so like performance tools, which are specialized for doing performance testing of web-based application. So there can be different kind of performance testing tool. One tool which is just used to do performance testing of web-based application. Another tool is also a performance tool, but it is specialized to do performance testing of back office software or server-based software. Then there can be static analysis tool for specific development platform. So static analysis tool for Java development platform, static analysis tool which is specific to .NET platform. Then dynamic analysis tool for security testing, or dynamic analysis tool for embedded system. So these are kind of some tools which are very specific to particular type of testing to be performed. Then tool support using other tools. So this means that tools discussed in this session is not a comprehensive list of tools used in SDLC. These are the tools. Whatever we discussed are some of the tools that are used nowadays in software industry, in whole software development lifecycle. There are so many different types of tools available, and there are many tools which are used in day-to-day activities which help to ease your task in testing. So some other tools are used by testers are like your word processors, spreadsheets, PowerPoint to do presentations, word processors, Word documents. Then SQL tool to write and execute DB queries, very common tool that is being used. Then debugging tools used by developers to debug defects. So like Eclipse IDE has built-in debugging tools, or there are many other debugging tools used. So there are a lot of other tools also used during SDLC. So to conclude, in this session we learned about tool support for test execution and logging, then tool support for performance and monitoring, and tool support for specific application areas, and tool support using other tools. Thank you.